In this video, we are going to learn how to simplify radical expressions. So for nth roots of n powers, for any real number a, the odd roots would yield just a, while an even root would yield the absolute value of a. And where we've seen this before is when we've seen the square root of x squared. The index of a square root is 2. And the power is 2, leading that to give us absolute value of x. Something similar would be like the fourth roots of x to the fourth. Again, x to the fourth creates a positive number, even if x is negative. So taking the fourth root of x to the fourth cancels that power out, but leaving with absolute value of x. But for a cubed root, for example, of x cubed, that would just give us x, because it could still be negative. Raising a negative number to an odd power still yields a negative number. So you don't need the absolute value there. So this is whenever you have an even root. Again, if it's a square root, it's understood to be a 2 in that top left corner. You don't have to write it. Then you'll have to use absolute value to make sure whatever number comes out of it is positive. Now, for each of these examples on the left, we're going to find each real root. So for example, negative 8, the cubed root of negative 8, you have to think of negative 8 as what number cubed. So you would ask yourself, okay, the way you get negative 8 is by taking negative 2 and then cubing it. And what I can do is now cancel out those powers. The power with the roots leave me with negative 2. So the cube root of negative 8 is negative 2. Now, what is the square root of 0.04? Well, I'm imagining what number squared is 0.04. 0.2 is 0.0 is squared. 0.2 squared is 0.04. So the square root of 0.04 would be 0.2. Now, the fourth root of negative 81, so I'm trying to think of what number to the fourth power would give me negative 81, which brings me into that imaginary root territory, because anything raised to the fourth power is going to be positive. Now, I know that 3 to the fourth is 81, but because it's negative, it will not yield a real root. So I'll have to say there's no real roots. Now over here we have the square root of negative 7 squared. So if you already notice that you already have something that is squared, I can cancel out that power with the square root, and since they match and it's an even root, I know I'll get the absolute value of negative 7, which simplifies to 7. And in case you don't understand why that can happen, well, what is negative 7 squared? That would be 49 and the square root of 49 is 7. So either way, you'll get to that correct answer. Now let's look at the fifth root of 1024. Now 1024 is a special number. It is actually known as 2 to the 10th as well. You see that number often used with computers. But now we have 2 to the 10th, which is definitely, the power is definitely bigger than the roots. But you can also think of 2 to the 10th as the same as 2 squared to the 5th, since 2 times 5 is 10. And now you have that fifth roots. And since it's an odd root, I'll have to use absolute value, leaving me with 2 squared, which is 4. So another way you could have approached this problem as well is to think of it as 2 squared to the 5th, which is the fifth root of 4 to the 5th. And you end up with 4 that way as well. And in one more way you could have gone about getting to 2 squared from 2 to the 10th, oftentimes these roots, these indexes, divide the power on the inside. So 10 divided by 5 is 2, and that's what leads to the answer of 4 for 2 squared. And we have the square root of negative 49, and we've definitely just saw this earlier, but even with the square root, I know 49 is 7 squared, but no number squared would ever yield a negative number unless it was imaginary. So again, there's no real roots for this one. Now let's look at this with some variables, because now I showed you how to do it with numbers. Now if you have variables involved, x could be positive or negative. So I'm taking the square root of 16x to the 8th. I'm thinking to myself, what number squared gives me 16? 4 squared. And what number squared gives me x to the 8th? Well, it's x to the 4th squared. When I take the square root, since I'm taking an even roots with that power, I'll get the absolute value of 4 times the absolute value of x to the 4th. Now, the absolute value of 4 is just 4. And the absolute value of x to the 4th would make that variable positive. But since x to the 4th is already positive, the absolute value is redundant. So I can just write this as 4x to the 4th. And again, if I look up at the top here with x to the 8th, that's also always going to be positive. So I know it can work with the square roots. Now over here we have a cubed root, which I can think of a to the 6th as a squared to the 3rd, just to match the index. 2 times 3 is 6. And b to the 9th I can think of as b cubed to the 3rd. That would give me 9. And now you're matching that index, so they can start to cancel out. And with it being odd, there won't be any absolute value bars. So my answer just becomes a squared b cubed. Now I hinted at this approach in the last problem, but now you can even think about just dividing those powers with the index too. So right here, the 4th root of x to the 8th, I can just do 8 divided by 4, which is x squared. And then 12 divided by 4, which would be y cubed. And again, I have to approach this with an even root, meaning those would be in absolute value bars. Since they could have been negative, but being raised to the 8th and the 12th would have made them positive. So I need to make sure I get a positive number in the end. X squared is always going to be positive, so it doesn't need to be in the absolute value. But y to the 3rd, we talked about earlier, is when you raise a number to the 3rd power, it can be negative. So I need to keep y to the 3rd in the absolute value for this expression. This is always just a check to make sure that whatever number we get from a 4th root, or a square root, or a 6th root, any even numbered roots, is positive. So I'm just making sure. Now, if there was a way to stop that from happening earlier, meaning, let's say we had y to the 3rd on the inside at one point, then I wouldn't have to worry about using absolute values, since the y being negative would have caused it to be non-real to begin with. So I'm really just looking out to make sure I catch that. If the inside's always going to be positive, then the outside should always come out to be positive, for sure. Now over here I have negative 32, y to the 10th. And again, to get negative 32, another trick I can use with negatives inside of odd roots, like we saw earlier, you can actually factor out that negative to begin with. So you don't even have to worry about it. Negatives are fluid here, but with even roots, the negatives can't really come out without it being an imaginary number. So that's why we don't mess with them there. But we can just factor out that negative, and now we have 32, y to the 10th. Now the 5th root of 32 is known as 2 to the 5th. So the 5th root of 32 is just 2. And then the 5th root of y to the 10th, 10 divided by 5, be squared. And I don't need to worry about absolute value for an odd root. So I end up with this expression. And that is how you simplify radical expressions.